Yes. So before we move ahead, what do you think is the idea of database? What is database? What's your take? Whatever, right?
Collection of data.
Collection of data. Okay.
It is something where all the data is stored.
Correct. Now, so do you think that Word file is also a database? Because Word also has a lot of data stored, right? Word file, Excel file, Notepad, for example, right? Your PDF.
Yeah, we can call it database.
We can call it database. Of course, we can call it database. But from computer perspective, okay, these are your special softwares. Okay. Special software, of course, Notepad, Word document, Excel, PDF, these are all kind of database because it has all the data. But in programming or in software perspective, in IT perspective, these are special software which are designed to handle, okay, large volume of data. Okay. Now, when you say special software, of course, we don't consider Word, Excel, Notepad, PDF as database. We have database like Oracle, SQL Server, IBM's DB2, Postgres, MySQL. Okay, these are the ones we consider as database because these are designed. Okay, the purpose of designing this software was to handle large volume of data. Now, why do we say handling large volume of data? Of course, your Word document can handle large volume of data. Challenge here, when I say here, it is non-database software like Word is that writing is easy. You can write anything to it. But reading can become very difficult, right? You have to go through each pages. Even if you have indexing, you know that, okay, it is on page 39, but on page 39, which line, which word, right? So when you say handle, okay, handle means, okay, you're reading, reading and writing. Okay, writing doesn't, of course, it means writing. It also means editing and deleting. Correct. So you have one main aspect, which is reading aspect. Okay, and we have second main aspect, which is called writing aspect. Reading is how do you read the data from it. Okay, writing is more about how do you save the data into it. So database software, so we call them as DBMS. Okay, DBMS, database management software. Okay, so the DBMS softwares are designed to make reading and writing easy. How do they do reading and writing? By using SQL. Okay, so SQL, which we will do after few days of learning, SQL, which stands for structured query language. Okay, it's called as language of database. And the concept, the idea behind it is very similar to whatever language you would have done, Python, C, C++. Okay, the idea is that, but it is designed specifically to handle databases. Now, which database? We have so many databases, right? Oracle has its own, Microsoft has its own, IBM has its own, and there are tons of other databases which are all used. So SQL is designed is governed by a rule called ANSI standards. Okay, ANSI is a rule that decides the standard. Okay, that sets the standard for SQL, and each of these vendors, software companies that make these softwares, have to follow this standard ANSI standard. Okay, so that's why the language SQL can be used to connect to any database. When I say any database, of course, we haven't spoken about types of database. Okay, and the most important of all, okay, is your RDBMS, which is Relational DBMS, the Relational Database Management System. Okay. Now, so this SQL, okay, now that we know the types of database, okay, and probably we'll know more about it, okay, is for RDBMS. Okay, relational database. Okay, so let's understand different types of database quickly. Okay, and we are not going to focus more time on what we don't need, but we'll focus more on DB, right? How the things they have evolved, right? You don't evolve, um, um, you know, what you need on day one, right? We have to start from somewhere, right? Now, so first type of database, you know, they're called centralized DBs. Centralized are very similar to your notepad or Word document, where everything is dumped and you go and figure out. Okay. So initially, when things was not that complex, when you didn't need to, there was no need for complex systems. People managed information in the notepad. Okay, you can even have CSV files, JSON files, etc., where you can survive. Okay, where maybe you have 100 rows of record, 200, 500, maybe 1,000. Okay, you can manage, right? But then it when started getting into hundreds of thousands, right? Millions of record. That's when those softwares wouldn't support. Okay, you can't put so much of data in a text file, and text file won't even load, right? So if you talk about advantage of this, okay, it's a single repository, single file available. You don't have complex installation that is required. You just open a notepad, start typing all your information. Even, you know, I'm sure that some of the smaller things like you know, what to you know, buy from grocery store, right? You'd probably, if you are tech savvy, probably you'll be typing in notepad, right? Which is manageable. Okay, you don't need fancy software. You don't have to install anything, right? But the problem is you can't have large volume of data. Accessing becomes difficult, and at the same time there's no security around it, right? You know, if I log into your computer for some reason, I can have access to your files, isn't it? Then people started talking about distributed databases. Okay, so you know, distributed database are where you don't have it at a single location, but you start distributing. So if I need to store your information, I will put my database on your computer. Okay, and that's how my application will talk to your database. Okay, again, problem is with that, if you format, your database is gone, right? At least in centralized, I have the responsibility of managing everything, but there it's gone. People started talking about hierarchical database. Okay, but none of these things became as popular as a relational database. Okay, so finally, RDBMS, we kind of fixed to RDMS. Okay, there are a few rules that one has to follow in order to be your database to be called as RDBMS. Okay, so what is R in RDBMS? Okay, R in RDBMS is relational, where it says that, okay, the information that you save, okay, in database can be okay. So again, sorry, let me take a step back. Okay, it was around 1970s. Okay, I think it was EF Cod. I'm sure about the last name. Okay, so Cod, he was a scientist working at IBM, and he came up with this RDBMS idea. Okay, and he mentioned few rules. Okay, and then let me talk about those rules, and then we'll see how and why our word came. Okay, let me open an Excel. Okay, Excel is not an RDBMS software, but it is very good tool to explain what I'm talking about. I think you should be able to see my Excel, right? So, so first rule that Cod said was that, okay, every information should be saved, okay, in a every information needs to be saved, okay, uniquely, okay, in the sense you should be uniquely able to identify a particular information, right? So let's say if I save, and let me think of a database, okay, let's talk about library database better, okay? So if I'm talking about library database, I should be able to know each information, like let's say if there is a member called Sachin, how many books he has taken from the library, on which date. I'll say, give me the date on which he has taken a book from library. So you should give me just the date, right? You don't give me the complete paragraph saying Sachin came on so and so at so and so time, he logged in here. So I just want date, okay? So you might have all the information, okay? Now when you create an account to Amazon, and when you log into your Amazon account, Amazon tracks everything that you do. What time did you log in? When did you log in? Which screen did you go? Which product did you search? Which product did you add to cart? Which product did you buy? Okay, which product did you arrived at your destination? Everything, all the information, even you buy or not, they keep track of all the information. Okay, but all the information you don't need at all the time, right? in Amazon database, if you log in, okay, most like probably we go and log in to see the product, maybe availability, cost, price, all those things, and then maybe you order. Rarely, okay, you go and see what happened to the product, or which product did you buy last month. Maybe you bought a computer, you want to get the warranty card, then probably you log in and probably you'll go 2 years back and see. Okay, so we do use, but that's rare, right? So based on whether it's user, can be anybody, right? User can be user like us, customers like us. I want to see the status of my product. It could be the database administrators, right? It could be in this case even the vendor, right? I ordered a book from a publisher. The publisher should be able to access who ordered the book, so that publisher can arrange for shipping of the book, right? The same information can be seen by multiple users. So it says that each information has to be uniquely identifiable. Now again, if you write that in a Word document, it becomes very difficult. You can pick a line, you can, but that particular information is difficult. So Cott came up with this concept of rows and columns. Okay, he said that information should be stored in a table format. Okay, should be stored in table format. You will have columns and rows. Okay, each row in RDBMS language, we call them as record. Record is nothing but rows. Okay, record, each of these are called record, and this is called tuple. Okay, tuple is nothing but column. Okay, what is tuple in RDBMS? It's column only. Okay, record is rows only. Okay, but you will hear mostly these words, tuple and record. Okay, this is one record. Okay, this is one record. Okay, because these are all the related information. And when you talk about tuple, okay, tuple should have a header, right? It should have header. So let's say I'll say book ID. Okay, book title. Okay, author, price. Okay, let's say I have this information. Now, let me add one more pages. So what it says is your tuple, okay, should have same data type in a column, right? If it is book ID, first column or first tuple is BID, everything under this should be BID, correct? Everything under this should be title of the book. Okay, now record also has some kind of uniquely identifiable thing. Okay, we'll talk about keys in some time, but even if you don't have keys, they put a row ID, which is machine encoded thing. They have something, their row ID. Okay, each of them will have row ID. Okay, so row ID 1, 2, so on, which is automatically given by the database. But what it says is each record should be related. So if book ID is, let's say, 100, okay, and it's called Python learn, right? And if author is, say, Lakshman, and price is 300, pages are 290, right? It means all these informations are related. All this information is related, isn't it? Okay, they talk about same product or a record. Okay, so information in row are related. Information in column has to be of same type. Now, each of these is uniquely identifiable cell, and each of these cell should give us that unique information. Who is the author of book ID 100? Or who is the author of book title Python Learn? Right? You should get Lakshman. What is the price of book ID 100? 300. You're able to get this information automatically. Okay, so that's why it is important for us to create this kind of structure. So that's the first rule. Okay, that information has to be stored in tuple and record format. Each cell has to be identified, okay, and can be accessed, read, can be edited, deleted, or modified. Okay, so all the database which claim to have RDMS, which claim to call itself RDBMS system, should be able to implement this. That's the logic one. Second logic it says is information should not be duplicated. Information should not be duplicated. Okay. Now, for example, let's say I have one more column called as publisher, and I have one more column called publisher phone. I have one more column called publisher head office or address, right? Publisher account number, let's say, because I need to make payment. So publisher account number. Now, let's say if there are 101, 102, 103, all these books are by, okay, EK publisher, let's say. All these books are by same publisher. Now, what happens? Since they are same publisher, their phone number will be same. Their head office will be same. Right? Their account number will be same. Right? So we are violating the rule here. We are duplicating so much of information, isn't it? One, it's going to take a lot of space, right? You're duplicating thing. Okay. So space is obviously concern, but even bigger concern is that maintenance becomes very difficult. Unnecessary, your table is growing. One. Second, if I have to change, let's say account number got changed. So you have to update so many account numbers, right? What if you miss one account number? Gone, right? So in this case, okay, we talk about the relationship between the book and the publisher. Okay, so one book ID will have only one book title, right? One book title will have one author, one price, on one pages. So if you talk about the relationship between these columns, it is one-to-one relationship. The word relation comes from here. All these columns have relationships. That's why you are able to put them together. If there was no relation between BID and book table, why would you put them together in the same record? No, it will be probably in different table, right? So your relationship is there, it exists, has to be there in order to put them together in the database. And this relationship can be 1:1, okay? So 1-to-1, it can be 1-to-many, or many to one, or you can have many to many. Okay, this is why we call this as relational database. Okay, there has to be some relation. So book ID, one book ID will have only one book title. Okay, one book title can have one author or multiple author, right? Now, if you have multiple author, okay, if you have multiple author, okay, then it becomes one to many relationship. One book, multiple authors. So your book and author will have one to many relationship. So if you put book here and author here, one book, multiple authors. Yes or no? So in this case, we call it as one to many relationship. Right? But for book ID and book title, one book ID will have only one book title. One book title will have only one book ID. So it is one to one from BID to book title, and also from title to BID it is one to one. So it is called one to one relationship. Okay, here you can have one to many relationship. One author, sorry, one title, multiple author, one to many. Okay, now if you talk about publisher and book, publisher and book, one book, tell me, book and publisher, what kind of relationship you have? One book will be published by many publisher? Yes or no?
Only one
One book.
publisher will be there, right?
Yes, correct. One book
Others
will
will
be
be more
published by
by only one publisher.
exactly. Okay, so one book will be published by one publisher only, but one publisher will have multiple books. So it is
Yes.
many to one. Okay, this situation you have many to one, or okay, one to many, many to one. Yes. Okay.
Swapnil,
Yes.
but in the first, I mean, initially only you said when we are considering these publishers' information, we are
Mhm.
violating the rules of DBA,
Correct,
relational
correct,
database
correct, correct.
management.
So this is not the right way to design. Okay, I'm coming to that point.
Okay.
Yes, this is violating, and that's why this is not the relationship. We cannot stop, right? If there's one to many, okay, and then you can have many to many also, right? Um, say offices, for example. Okay, let's say you have a college library, and this college or university will have multiple centers, and publisher will also have multiple offices. So if you want to map offices, like which office should deliver books to particular library, right? So in that case, you end up getting many to many relationship, right? Okay, so whether it is one to many, many to one, or many to many, okay, we have to manage that relationship. Okay, why? Okay, why? I told you, because editing becomes difficult. Editing becomes difficult. Reading is very easy. Okay, you just read and you get it. Reading is, now let's say if this information will never ever get changed, probably we can prefer this way. Okay, but account numbers can get changed, head office can get changed, phone number can get changed. You cannot say no, this will not get changed, right? So what it says is, it in the sense database logic says is, if you have one-to-one relationship, you can put all those information in single table. If you have one to many or many to one, then you need two tables. So in this case, we have one to many, right? So what we'll do here, we will put another table, we'll create another table here. Okay, we call it as publisher info, publisher. Okay, and we'll have one publisher ID, just like we have one book ID, PID, and PID can be 100, 101, 102, 103. Okay, so you have one table which has publisher information, one table which has book information, but now these two are not related, isn't it? How do we link these two tables? There is a relationship between them. So we say, okay, let's create a foreign key. And we'll talk about key, but just to understand that foreign key is a column pub ID, okay, or whatever, PID. So foreign key is a column of another table which is added here, okay, so that we can link these two tables. Now, let's say if all these, okay, are published by, PID 100, okay, no, obviously here you'll have different publisher, right?
Yeah,
So,
that's what I was thinking.
yeah. So if all of these are published by same author, right, you'll have PID as 100. What we just did is we created this model. Okay, we call it as creating a model. We created two different tables and we added a key which will join these two tables. So if I want to know the head office of the publisher which published this book, okay, now I cannot get directly from this table, but using this PID, which is foreign key, I can go to this table and I can pick the head office. So now, and later when we do SQL, we will see how to do programming and get it. Okay, but now at least you understand from theory that yes, we can link these two tables and go and get the information from here. Yes. So when you have one to many, okay, we prefer to have them in two different tables. But what about when you have many to many? Okay, so in same library example, let's say you have members record. Okay, you have members table and you have, let's say, book table. Now, members are allowed to take multiple books. Of course, you have multiple copies of the book. So, one book can be taken by multiple members also, right? You have 10 copies. So 10 members can take it, right? And one person, let's say you allow 5 books to be issued to a single person. So you can, they can take 5 books. So in this case, we have many to many relationship. More than one is called many to many. Okay, many to many relationship, right? So what do we do? Of course, you will have one table which will have members information like member ID, name, address, phone number, membership type, etc. You'll have book table, which is this one, right? But how do we link members and book table? We'll end up creating one new table. Okay, we end up creating one new table where you have, I say transaction. I'll call it as transaction table. Okay, I call this as transaction table. Transaction table will have TID, transaction ID, will have the MID, member ID, will have the book ID. Okay, and let's say date of issue date, and let's say return date. So what we did, okay, we created third table. Okay, we already have members table, we already have book table, but that is not useful for us. So we created transaction table and we are saying we'll have TID 1, 2, 3, 4, 5, so on. Let's say first book member 1 took it. So I'm going to say 100 and he took 100 BID. Okay, and of course you can talk about issue and return date. Now same member took book 190. Okay, different member. Okay, sorry. So let's say 110 took one book ID 190 also. So you're able to manage many to many relationship here. If I want to know how many books member 100 has taken, 100 is member 100 is, let's say, Sachin. How many books Sachin has taken? I'll just go here and see. Okay, so has taken 10 books, but out of these 10 books, 7 books have a return date. So if they have return date, that means book was returned on so and so date. So how many books still has? 3 books still Sachin has it, because they do not have return date entered into the table. So when you have many-to-many relationship, we create 3 tables. 2 tables to maintain one-to-one among themselves, and third table to link these 2 tables together. Okay, we will slowly build our library database. We'll see. Any questions so far? Okay, before we end, I'll start one more concept and we'll stop it. The concept is your OLTP versus OLAP. Okay, OLTP stands for online transaction processing, and OLAP is online analytical processing. Okay, main difference between OLTP and OLAP is OLTP, bulk of the operations that we perform is your writing. We discussed about read and writing, isn't it? And writing would mean, of course, writing new record, editing existing record, deleting record. And OLAP, bulk of the operation that we perform is called reading. Okay, data analytics. So we are going towards data analytics side. Okay, so OLAP is what is important for us. This is what we need to get deeper. When we talk about warehousing and things like that, we'll get into this. But since we're talking about database, let's also talk about this. This is more like application database. Amazon will have this database. Okay, but if Amazon wants to analyze their record, okay, what happened last month, okay, which was my top selling, which vendors sold most, which customers bought most, which are the customers which have some you suspect something fraud in the buying, things like that. So for that, what you'll do, you will take your last month data offline. You won't start working on the same database which is live and running. Okay, you will take a database offline and you will process on it. So the requirements for database which is online for analytical processing is different than for transaction processing. Transaction processing focus is on speed. Both the thing is focus on speed, right? You want to get result faster. But in analytical processing, okay, you will be querying hundreds of rows. But in transaction processing, you'll be querying only one row. You want to edit one data. When I log in, Amazon will enter only my data, will edit my data into the database that sort of entered, right? So the concepts are totally different. What is good database concepts? Generally, when you Google saying what are the good database concepts, or in fact, what I have been talking about relationship, holds true for OLTP, not so much for OLAP. Okay, the concept that if you have single table, I mean one-to-one makes single table, one to many, multiple tables, many to many, 3 tables. These are all concept of OLTP. Okay, because mostly it is writing, and you'll have to write. If I have to update one thing, okay, you have to update multiple rows, right? So in a publisher, right, headquarter changes, you have to update multiple places. Since the focus is more on writing, focus is more on editing, okay, we don't prefer that. We prefer it to be different, so that whichever, right? Okay, I'll give you this bad example, but it'll help you to remember. Let's say you joined a class, you're doing some course, okay, and you have 5 subjects in your course. Now, whether it is good idea to have 5 different notebooks for 5 different subjects, or have only one notebook for 5 different subjects. See, if your subject demands writing, okay, you attend the class and they make you write differently, then you will prefer 5 different notebooks, because so if you're talking about mathematics, that okay, this is the notebook I have to talk about or I have to write into. so that tomorrow when you're preparing for maths exam, you'll take out your maths notes and you'll study. Okay. But if it is about reading only, it is better you club them all together and form one book. You don't have to go through multiple books, isn't it? Bad example, but this is what happens. When you're doing writing, you prefer smaller things so that you know where you need to write and other, let's say if you have 5 subjects and I divided my notebook into five equal sections. And if I have to exceed if I have to exceed first section, I'll not have space to write in second section because I've already marked it as for second section. So you don't have much visibility in what's coming. Okay. So for first few days, okay, we'll talk about OLTP only because that's a good database practice. And when you say, database, people expect you to know these concepts. And then when we turn our attention to an analytics, we'll say, no, whatever you have read is not correct. Focus on this. Obviously, because analysis is done on data which has already been done. Okay. So if I have to perform some analysis on October data, I will not have to make any edit. Correct or not? I don't need to make any edit because if you have to make any, that means you are tampering the data. So for analytics, we don't do any edit until unless if there are some if data is not in proper format. Okay, if there's some error into data, so we do data cleaning. But we don't edit the data. Data is what customer has already bought last month. Okay. In NLTP, since it is live, right? It's about the current transactions. So it should be able to capture the data. Okay. So that's the difference between OLAP and OLTP and, the relationships in database. Okay. We'll stop here for today. Okay. Tomorrow, we will get into the different properties of RDBMS. Okay. We'll talk from the OLTP perspective for next few days. Because the table design, good query writing, all these things happen from OLTP perspective only. Any questions so far? Is it clear what we have done? We have just done 3 concepts today. We talked about what database is. We spoke about the different relationships that exist between the data. Okay, and the OLTP versus OLAP. Tomorrow when we meet, we'll look at how to create a table, okay, and basically how to store a data. Okay, how to store a data. So when you start creating a table, we'll give lot focus there so that when we get into practical, you can take the same concept and start implementing in your database as well. Okay, so we'll talk about database and we'll also talk about different types of data structure and things like that. Make sense? I'll share the recording in some time. So at least in theory, you know what database is now?
Yes, sir.